Welcome to the What's New presentation of MDA 8.5.3. My name is Matthias Gäkeler. I am at ETAS the Product Manager for MDA. Within the next about 12 minutes, I will present you the topics listed here. In case you want to access a topic directly, you can use the jump marks listed below the video. I'm starting with a minor change done for the command line tool MDF Combine Exe. Two arguments were renamed. This was done to avoid confusion between the term pause, which means an interruption of data recording within a measure file, and the term gap, which stands for a time gap between separate measure files. The new argument names are gap and gap threshold. Additionally, short forms were introduced for both. The functionality itself was not changed. It enables to merge measure files chronologically into one. The combined measure file includes one additional signal named file, which I'm going to use in the next section. The following topic sounds inconspicuous. Nevertheless, it represents an essential improvement for a correct signal curve drawing. What is it all about? For performance reasons, the signal curve in an oscilloscope is drawn based on reduced data, avoiding to load all samples for the signals. Simplified, this means that for each vertical pixel column, just the minimum and maximum value is given to the oscilloscope. In case there are time ranges for which no samples exist, like in a start-stop situation, the question arises: how to draw the signal curve correctly across the gap? If, for the last pixel left of the gap, only the minimum and maximum values are known, basically only these can be used. But these values do not necessarily represent the actual last value before the gap. To overcome this ambiguity, MDA 8.5.3 detects for specific signals whether a gap situation exists, and if so, the actual last sample is refetched. Now MDA 8 can draw a clear and true signal curve even in such specific cases. I'd like to demonstrate this by means of a special signal. In the previous section I showed how to merge several measure files. Thereby a signal is created which has two samples very close to each other and then a larger gap without samples. When this signal is added to an oscilloscope, the gaps are detected, and for each gap the last sample before the gap is fetched. Accordingly, the correct connection line is drawn. As a critical and attentive observer, you might argue that my example signal does not prove this. Indeed, the same signal curve would result if the maximum would be used for the connection line. Therefore, I created a special file in which additional samples were inserted between the relevant samples. This can be seen by the vertical lines at the times when the former signal changed. When zooming in, you can clearly see that MDA is detecting actually the last sample before the gap, and that its value is used for the signal curve across the gap. As the detection of the gap requires calculation capacity and time, the check is currently limited to discrete signals like enumerations and signals in the Boolean strips. Two smaller improvements were implemented for the oscilloscope. To facilitate the handling of creating a separate strip for a single signal, a context menu entry was modified. Move to New Strip and the corresponding hotkey Ctrl+T is now also enabled if just one signal is selected. Moreover, the missing instrument properties of the oscilloscope were added to the Properties docking window. These are properties for the cursor navigation and behavior, as well as the definition of columns shown in the oscilloscope signal list. Now for all instruments their properties are listed completely in the docking window. And the cleanup of the oscilloscope's toolbar is finished so far. With MDA 8.5.3, also some improvements for the export functionality are introduced. Basically, there are several entry points to trigger an export. Depending on the actual context, some defaults are set for the time range and the signals to be exported. In case the export is done directly from the level of a file entry in the File Explorer, all signals of the file and the file duration are preset. You can change the time range and the target file format. Latter is helpful for the typical use case of a file format conversion. In case you want to export a defined subset of signals, this can be done from the Variable Explorer. The selected signals will be combined into the export file. The preset for the time range is defined by the time ranges of the respective measure files. If a time offset was defined for a file or a signal, the shift will be included in the export. Finally, an export can be triggered from some instruments like the oscilloscope. All signals assigned to the oscilloscope, as well as the visible time range, define the preset for the export. With MDA 8.5.3, you can extend the selection of signals via a drop-down to include all signals from all sources into the export file. All sources means from all measure files as well as calculated signals. The second useful enhancement helps me to demonstrate the described behavior. For each export process, a progress indication is shown. For any export finished successfully, an entry in the context menu allows to see the export file in the Windows Explorer. The total number of the signals in the configuration is visible in the Variable Explorer. When adding the just exported file, the number of signals gets doubled. And by adding one of the new signals to an oscilloscope, it can be seen easily that just a time segment was exported. Lastly, it can be mentioned that also for the creation of a label file, the export progress view is used. Thus, you can easily access the lab file in the Windows Explorer and continue to use these as desired. Next, I'm going to show an enhancement for the calculated signals, namely the lookup table function. Although the enhancement is limited to curves currently, MDA 8.5.3 allows to demonstrate the principal behavior. First, MDA requires the curve and its data. Therefore, MDA 8.5.3 supports to add a calibration data exchange file in CDFX format to a configuration. Such a file can be created in INCAS CDM, for example. The curves defined in the file are shown in the Variable Explorer. To demonstrate the behavior of the lookup table function, I have added to an oscilloscope a measure signal and some reference lines representing the axis breakpoints of the curve. Next, I'm creating a calculated signal for which I'm using the new function lookup table curve. It requires as a parameter the desired curve, as variable an input signal, and the setting for the interpolation mode. Hereby, 0 stands for constant interpolation. Let's see the result. Depending on the value of the input signal, the corresponding axis breakpoint of the curve is used to return the Z value defined there. This can be seen at the intersections of the input signal with the reference lines. At these points, the result of the calculated signal changes according to the values of the curve. Also in the scatterplot instrument, the lookup table behavior and the constant interpolation can be seen directly. The way how the lookup table functionality is implemented in MDA 8 supports especially two cases well. First, it is very simple to create further calculated signals, both with a different curve as well as with another input signal. Second, although the curves need to be modified externally by editing the CDF file's content in an editor, a simple replacement of the CDF file in the File Explorer allows to update the data without the need to restart MDA 8. For the next MDA release, version 8.5.4, another lookup table function, namely for maps, will be introduced. Moreover, the mode for linear interpolation will be enabled. As complement to the existing Inca add-on for bus trace recording, an extension for MDA version 8.5.3 is available. It allows reading and interpretation of the recorded BLF files. The corresponding Inca add-on enables the usage in MDA 8 as well. Then the configuration ribbon shows an additional button, which opens a dialog to select and define the required details. These are the BLF file with the recorded bus data, a DBC file comprising the needed CAN bus description, and the CAN ID. MDA stores this combination as an associated file format, AFF, and shows the file in the File Explorer. Based on the DBC description file, the bus data is interpreted and signals are derived. These are listed in the Variable Explorer and can be used in MDA 8 in the same manner as signals from ordinary measure files. Finally, I'd like to mention the What's New slides, which include more details about all the features listed here. The slides, as well as feature videos and further information materials, can be opened directly from the Help ribbon of MDA. I hope this presentation was useful for you. Thank you for watching it.